every black hole video starts the same way. A funnel, a giant cosmic drain, space curving downward into a point. You've seen it 1,000 times. Here's the thing. That image is wrong. Not slightly wrong, fundamentally wrong. And once you see what's actually happening, you can never look at space the same way again. The funnel shows space as a flat sheet with a dip in the middle. The black hole sits at the bottom of that dip, like a bowling ball on a trampoline. It looks convincing. It's in every textbook. It's in every documentary. It has one massive problem. It only shows 2 dimensions. Up and down have no meaning in space. There is no down for matter to fall into. That funnel is not showing you what space looks like near a black hole. It's showing you how time changes near a massive object. The dip isn't about space curving downward. It's about time slowing down. So what is a black hole, really? It starts with a massive star, at least 20 times the mass of our sun. For millions of years, the star burns nuclear fuel, and the outward pressure from that burning holds it up against its own gravity. When the fuel runs out, there is nothing left to push back. The star collapses under its own weight in less than a second. The outer layers explode outward as a supernova. The core collapses to a point, a singularity, a region so dense that the math breaks down and the normal laws of physics no longer apply. What surrounds that point is the event horizon. And this is where most explanations go wrong again. The event horizon is not a surface. You cannot touch it. It has no walls. It's not glowing. It is not a membrane. It is simply a mathematical boundary, a point in space where the escape velocity, the speed you would need to reach to escape the gravitational pull, exceeds the speed of light. Inside the event horizon, all paths through space-time point inward. Not some paths, all of them. Even if you fired a rocket at full thrust, even if you moved at the speed of light in the direction directly away from the black hole, you could not escape. The geometry of space-time itself has turned inward, like a river current so strong that no swimmer can make headway against it. Here's the strangest part. If you were falling toward a black hole and crossed the event horizon, you might not notice anything unusual at the moment of crossing. No explosion, no alarm, no physical sensation. Just an invisible threshold you can never come back from. Now, let's talk about time, because this is the part that changes everything. Einstein showed us that gravity doesn't just bend space, it bends time. The stronger the gravitational field, the slower time runs. We measure this effect every day with GPS satellites. Clocks in orbit run slightly faster than clocks on the ground because they're further from Earth's mass. We have to correct for this in the GPS system constantly. Without that correction, your maps would be off by kilometers. Near a black hole, this effect becomes extreme. An outside observer watching an astronaut fall toward a black hole would see something strange. The astronaut would appear to slow down as they approached the event horizon. Their movements would slow. Their transmitted signals would stretch. Their clock would appear to tick slower and slower. To the outside observer, the astronaut would never quite reach the event horizon. They would appear frozen at the edge, slowly fading, for the rest of the universe's life. From the astronaut's perspective, none of that is happening. They cross the event horizon in moments. Inside, gravity's grip on every direction is so total that even the concept of moving away from the center becomes meaningless. One more thing the funnel gets wrong. It suggests that if you stayed far enough away, you'd be safe, which is true, but it misses what makes black holes genuinely dangerous up close. The gravity near a black hole isn't just strong, it's uneven. The side of you facing the black hole is dramatically closer to it than the side facing away. That difference in gravitational force stretches you, lengthwise. The technical term is spaghettification. For a small stellar black hole, this would happen before you even reach the event horizon. For a supermassive black hole, the ones millions or billions times the mass of the Sun at the centers of galaxies, the event horizon is so large that the tidal difference across your body is actually small. You might cross it before you feel anything unusual. Black holes are also not eternal. In 1974, Stephen Hawking calculated that they slowly evaporate. Quantum mechanics predicts that near the event horizon, pairs of particles spontaneously appear from the vacuum of space. Normally, they annihilate immediately, but near the event horizon, one particle can fall in while the other escapes. The black hole loses a tiny amount of mass with each pair. Over an almost incomprehensible span of time, far longer than the current age of the universe, a black hole radiates away completely. What Hawking radiation leaves behind is still debated. And at the very center, the singularity, general relativity says infinite density, infinite curvature, a breakdown of all known physics. Most physicists don't believe there's actually an infinity sitting there. They believe our equations are failing. Something is happening at the center that requires a theory of quantum gravity which we do not yet have to describe. The most honest thing anyone can say about the center of a black hole is we don't know. So here's what every black hole video gets wrong. The funnel makes it look like space is bending downward toward a drain. The real picture is stranger. Space and time are woven together, and near a black hole, that weave distorts so severely that time itself slows towards zero, all directions curve inward, and the very concept of a way ceases to exist. Not a drain, a place where time stops, a region where the universe's geometry points only one direction, and that direction is in. That's today's science simplified. Follow for tomorrow's study.